Let's talk about simplifying radicals. So just some definitions to start with. Nth root of a is how we would read that. Nth root of a equals b if and only if a equals b to the n power. So the radical is the general term for that symbol for this type of calculation. The radical is saying, what do we multiply by itself this many times in order to get whatever is inside of here? N, the number that's kind of up there inside of the symbol, is the index. That's what we're saying, how many times this would be multiplied. The sort of V-shaped symbol with the bar is called the radical. And then the thing inside is the radicand. That's a much less common note, but just radical, no, in general, that means square root, cube root, any of those type things. If no index is written, that's the square root. So we don't bother to write a 2 kind of inside of that V part of the radical. That's the default if nothing's written. For an even root, we can't take the even root of a negative number. If we multiply the same thing times itself an even number of times, whether that thing starts out negative or positive, the result is going to be positive. So there is nothing that you can multiply by itself an even number of times and produce a negative result. But if the index is odd, then we can have positive and negatives. So perfect roots, if the root is a rational number, if there's a rational number that you can multiply by itself that many times to get the input, then that's a perfect root. General rule, basically the root and the power undo each other. If it's an odd root, if it's an even root, if you take the power and then the root, you could do that with a negative number. The power is going to turn it positive, then the result is going to be positive. So taking the power and then the root essentially makes that negative number turn positive. Square roots, again, that's when the index is 2. We're looking at what do we multiply times itself once to get this, or 2 factors of this of the same number to get this result. Negative numbers don't have square roots. The square root of 0 is 0. We assume if you just have square root of something that it's positive. If there's a negative out front of it, it's negative, even though, like if I look at square root of 4, I could multiply 2 times 2 and get 4, or negative 2 times negative 2 and get 4. But if I just say square root of 4, we assume the positive 2. On the other hand, if I start out and saying x squared equals 4, and I'm looking for x, then both of those, the 2 and the negative 2, would have to be included. As long as you could take the square root of something, then if you square that square root, you get back the original thing. And then, of course, if you take any number and square it, and then take the square root of the result, if it's a positive number, you just get the number back. If it's a negative number, you get the positive part of it, the number part of it without the negative. And this is similar for any even index, 4th root, 6th root, etc. Cube roots, the main difference is you can put any number in there. Cube root of a negative number is negative, cube root of a positive number is positive, and similar for any other odd index, 5th root, 7th root, etc. So some practice with perfect roots. Cube root of 8, we're looking for what do we take to the 3rd power to get 8. And if it's a perfect root, you can factor out, just find all the things you multiply together to get 8. 8 is 2 times 4, 4 is 2 times 2, so really 8 is 2 times 2 times 2. We have exactly 3 2's being multiplied together, so 8 is 2 cubed, and so cube root of 8 is 2. Some of these, hopefully you just pretty much have memorized, and cube root of 8 is 2, for example, without having to do this whole process. But if you're not sure, you can do that. Cube root of negative 64, so we're looking at what do we multiply by itself 3 times to get negative 64. And we know it's going to be negative, so we'll just stick the negative there and then focus on the 64. What is 64? depending how you recognize it, maybe 64 is 8 times 8, and then we just saw 8. Each of those 8s is 2 times 2 times 2. And so we have then, if we put these factors in sets of 3, or sorry, in 3 sets, each set is 2 2s, so 4 times 4 times 4. So cube root of a -64 is -4. Fourth root of 1/16. When there's a fraction inside, one thing you can do is apply the root separately to the top and the bottom. And so any root of 1 is just 1. And then fourth root of 16, if you know 16 is 2 times 2 times 2 times 2, 2 to the 4th power. The fourth root of 16 is 2. And we can also just look at 1/16 would be then 1/2 times 1/2 times 1/2 times 1/2. Then you could get there without splitting it up. The sixth root of -2 to the 6th, the rules say all it's going to do, the 6th power on the -2 is going to give a positive result, and then the 6th root is going to give back the 2, but just the positive. So we don't have to actually multiply it out and do that. I just know that when I apply the 6th power and then the 6th root, all it does is changes the negative to a positive. All right, properties of radicals. The root of a product is the same thing as applying the root to each factor separately. Similarly with a quotient or a fraction. Keep in mind that doesn't apply then to addition, subtraction. So you can't split up if it's a square root of things being added together. That can't be split up in any way. And then we have nth root of a to the m equal, you can do the power first and then the radical, or the radical first and then the power, essentially is what that's saying. This is assuming m and n don't have any common factors, and then if n is even, then a has to be positive for this to be true. All right, so simplifying non-perfect roots, the goal is we don't want any fractions left inside the radical, and we don't want any perfect nth powers left in what's inside of the root. So if it's a square root, we don't want any perfect square factors of what's inside of that, etc. So looking at what's inside of the radical, you can kind of rewrite that as a product of the perfect power times whatever's left, and then you can split that up into 2 radicals and simplify the one that can simplify, and then you have whatever's left. If there's a fraction inside the radical, the fraction rule says, again, you can apply that radical to the top and the bottom separately. And you keep checking until you make sure that none of those things are still there as far as fraction inside the radical or perfect nth power factor. Some calculators can actually do this process for you, others can't. I'll leave that to you to figure out whether yours can or can't. But yeah, so square root of 32, you might look at 32 and see, oh, that's 4 times 8, and 4 is a perfect square. And so you split that as square root of 4 times square root of 8, and that's 2 times square root of 8. But then as you keep looking at that, 8 also has a factor of 4. 8 is 4 times 2. So square root of 8 we rewrite as 4 times 2. And so we have 2 times square root of 4 times square root of 2. And that's 2 times 2 times square root of 2, or 4 square root of 2. Now, you might not need to write out all of those steps. So feel free to kind of skip any of those that you don't feel is necessary along as far as just to write down. But you might also look at the 32 and recognize right away that 16 is a factor. So the square root of 32 is square root of 16 times 2. So that's square root of 16 times square root of 2. Square root of 16 is 4. And so you get the 4 square root of 2 kind of in one step of this process. But either way, like, you get there eventually. So it's not wrong to do the more roundabout way. It just takes a little bit longer. And the next example, 4th root of 16 x to the 5th over 81. So I'm first going to split the top and bottom of the fraction. We have 4th root of 16 x to the 5th over 4th root of 81. And if we know 16 is 2 to the 4th, 81 is 3 to the 4th. So those are perfect 4th powers. So I'm going to split this up. So I have 4th root of 16. And then I'm even going to split up. So the x to the 5th is x to the 4th times x. So there's kind of an extra x there. So I'm going to split this 4th root of 16 times 4th root of x to the 4th times 4th root of x. And then on the bottom, the 4th root of 81. And now I'll go ahead and simplify. So we have 2x times 4th root of x over 3. Or I could write that as 2/3 x 4th root of x. Because there's still that x inside of the 4th root, x can't be negative, and so we don't have to worry about the 4th root of x to the 4th coming out, the absolute value of x, because x being negative wouldn't work at all anyway. Be careful with this. We have the x 4th root of x. It's not x to the 4th square root of x. So make sure that 4 is, inside, it's the index of the radical. So just watch with that notation that you're writing things clearly and then entering things in the correct place in MATLAB for this type of thing. So that's simplifying radicals.